Good day. My name is Konstantina Velkushanova, and I'm going to speak about the characterization of fecal sludge. I'm going to stress mainly on the qualitative assessment and properties of fecal sludge, as well as on the standard operating procedures for fecal sludge. The qualitative characterization has been already covered by Linda Strande in one of the other keynote speeches, and for that reason, I'm not going to cover it. I work at the Pollution Research Group at the University of KwaZulu-Natal, which is based in Durban, South Africa, and have been working in the field of water and sanitation for the last 4 years, particularly focused on fecal sludge characterization. What are the characteristics of fecal sludge and how do they vary? The fecal sludge characteristics are very heterogeneous. They depend on many factors, including environmental factors, such as geographical location, the demography of the region, then also climate conditions, the presence of underground water table, and also soil type. The type of on-site sanitation technologies is also an important factor, as well as the quality of the construction. Also, we have the age of the sludge and the filling rates. So the slower the filling rates, the less frequent the emptying of the sanitation facility would be, and then the more aged the sludge would be. So the more aged the sludge would be, then the more stabilized would be. Then also we have another factor, which is the toilet use, which is defined by different specifications, such as number of users and their diet. Also the frequency of the use, whether the toilets are dry or wet, whether they're flush toilets or there is no water introduced into the system. Also, what is the culture of the toilet use, whether most of the people are wipers or washers, as well as the addition of additives to the sanitation system changes significantly the characteristics of the sludge, and the disposal of gray water and trash into the system, as well as the frequency of the emptying and whether this is mechanized or manual. According to this, we can distinguish between different types of fecal sludge. We can classify them by the type of on-site sanitation sources, such as pit latrines, septic tanks, dry toilets, such as urine diversion or composting toilets. Also, depending on the age, the storage, or the source treatment, we can have stabilized or digested sludge, semi-digested sludge, or fresh sludge, depending on the type of use, on the type of system, whether we flush or not, we can have wet or dry. Coming back to the fecal sludge treatment targets and objectives, the main aim is to provide safe environmental and public health, which supports the entire chain of fecal sludge management, starting from treatment, discharge, end use, or disposal. To meet this aim, there are a number of objectives set, which are pathogen inactivation, stabilization of the organic and the nutrient matters, and also the safe end use and disposal. The dewatering is an important step because this provides significant reduction of the volume of the fecal sludge, which makes it a lot easier for transportation or further treatment. So what are the important parameters for fecal sludge characterization? I have summarized in a table some of the most commonly used and essentially the most important parameters for fecal sludge characteristics. Some parameters are not included here. This doesn't mean that they are not important for specific types of technologies or specific purposes, but then this is a broad summary. I have grouped them into 4 categories, and the first one is chemical properties. These include moisture content, total solids, suspended solids, ash content, and volatile solids content. Also, COD could be total or fractionations of the COD, pH, also ammonium, TKN, phosphates, orthophosphates, potassium, etc. In the last column, I have included the reason and the importance of why we need to determine these kind of properties. For example, if we take the moisture content, this gives us an assessment of the mechanical behavior of the fecal sludge as a material for processing like mixing, drying, flowing, or combusting. It is also an indicator about the biodegradation potential of a sludge, knowing also the age and the COD in combination with the COD values. And also, it's a good indication about the potential migration of pathogens. If, for example, we take the ammonia, TKN, phosphates content, and potassium, this gives us the nutrient recovery, the potential nutrient recovery values, given that the fecal sludge has been treated for pathogen inactivation. The next group is physical and mechanical properties, such as density, particle size distribution. Also, we have sludge volume index, osmotic pressure, rheological properties, and sludge penetration resistance. Why are these important? They provide background information which could be quite essential for the design of pit-emptying devices or mechanical treatment of fecal sludge. If we take, for example, the rheological properties, they give a good estimation of the change of the viscosity with increasing shear rate, which also provides the essential information for design of pit emptying equipment and also mechanical treatment processes. The next group is thermal properties. They're mainly important for thermal thermal treatment processes or design facilities. For processing such as combustion, heating, and drying. Here we have incorporated thermal conductivity, specific heat, and calorific value. Also, the last group is called biological properties, which incorporates parasites content and pathogen content. They are very important, coming back to the aim at the fecal sludge treatment, providing safe public and environmental health. So if we take, for example, the Ascaris content, this is a very important indicator. Why? Because the Ascaris eggs are very resistant to any type of treatment technologies. So it's considered that if we manage with a certain treatment technology to destroy the Ascaris eggs, then supposedly we have been destroyed already any other pathogens present in the sludge. What are then the challenges when we measure such fecal sludge properties? We mentioned already that the fecal sludge is highly heterogeneous and varies between different conditions or different sanitation facilities. So if we take sludge coming from different on-site sanitation facilities, the properties may vary highly. But also, if we take the sludge coming from one and the same type of on-site sanitation facilities, but from different toilets, we can observe a high variation as well in the properties, depending on the number of users, the load, etc., factors that we mentioned early on. And for that reason, we also have high variation of the properties when we collect sludge coming from one and the same toilet facility. Why? Because at the different sections of the sludge, you have different degradation rate, hence different moisture content, and this would also result in heterogeneity of the sludge properties within one and the same toilet facility. So what is the correct approach for measuring the fecal sludge properties then? This would be the development of standard methods and procedures, also called standard operating procedures for fecal sludge analysis. They could be applicable for the sampling process, for all the different analyses we mentioned, whether the analyses are performed in the field or in the lab conditions, and also covering all the health and safety procedures during the entire process of sampling, transportation, storage, analysis, and disposal. So the SOPs having standard operating procedures is important in many fields for various reasons. Some of them are summarized here, like consistency and reliability of the data, also good quality control, efficiency of the testing methods, reduction of the errors, and health and safe work environment. Currently, there are no standard operating procedures for fecal sludge measurement, and standard methods for water, wastewater, and soil are adopted for the fecal sludge. However, these methods are not the most suitable because the fecal sludge differs in its characteristics by this method. As we said, it's highly heterogeneous, but it also has higher solids content compared to water or wastewater. And then we have a high variation even between the different sludges coming from the different on-site sanitation facilities. So the lack of standard methods for fecal sludge results in incomparable data sets generated between different regions and institutions, which is already raising a problem. What would be the way forward? There is a need of collaboration between institutions working on fecal sludge characterization for development of standard operating procedures for fecal sludge characterization. And this will not be a once-off task because the methods evolve and change over the time. So I'm going to move to an example from the pollution research group where we did a development of standard operating procedures for fecal sludge, and we did research on certain properties. So first of all, to start, we have a specialized sanitation laboratory which analyzes a lot of samples from fecal sludge, different excreta, human excreta, such as urine or fresh feces. Also, we analyze wastewater or sludge coming from wastewater treatment works. For a bit more details, you can have a look at our website. What we also have is, during the last couple of years, because we have been working extensively with properties of fecal sludge, analyzing and then investigating, then we have developed a standard operating procedure manual which is specialized for fecal sludge. So we have a couple of sections there. The first one is administration section, which is focused on the different documents that need to be filled in before we go to the field for sampling, or before we receive sludge samples from somewhere, or before we initiate any further analysis. The next sections incorporate already the different groups I've already mentioned of properties, although in our manual there are a lot more properties mentioned and it's given in a lot more details. And then there is another section which incorporates the laboratory health and safety standard operating procedures covering the entire process. For more information, you can download our standard operating procedure manual for fecal sludge from our website again. And I would like just to stress on the fact that we call it an SOP manual for fecal sludge, but that's our internal document so far. We have disseminated this document to a lot of our partners. They have been using it as a basis for their methods, and that's the way to go forward. But this is not an official document that has been issued for fecal sludge yet. So I'm going to move on to a specific study I have been working on, which is called Mechanical Properties of Fecal Sludge. Why? Because it incorporates quite a lot of properties of fecal sludge that have been studied, and it gives a good example of what is the importance to do analysis and characterization of fecal sludge in a good quality and using standard operating procedures. The project is funded by the Bill and Melinda Gates Foundation. It has been already completed. The main objectives were to generate first-hand data for fecal sludge characteristics from dry on-site sanitation facilities in Durban, South Africa. And then the other objective was to provide data for improved design or sizing of pit emptying devices or devices for transport and processing of sludge. There was an extensive pit emptying program focusing on dry on-site sanitation facilities. We have emptied a number of different ventilated improved pit latrines, which were on a household level or community ablution block or school level, also urine diversion toilets and unimproved pit latrines. We have also aimed at a different usage level, which incorporated low use with less than 5 users per facility or high use with over 5 users per facility. And then, when the project started, we firstly proceeded with the sampling. So what we realized then is that no matter how good our standard operating methods for testing and analysis in the laboratory are, because of the heterogeneity of the fecal sludge, we have actually questionable data set once again when we speak about sampling. So, for example, I mentioned early on that we can have large variation between sludges coming from one and the same type of facility or from different ones. So how do we ensure when they have different filling rates, when they have different age, how do we ensure that the data is comparable between each one of them? So what we did firstly was with the dry household ventilated improved pit latrines, we selected samples from 10 dry and later on 10 wet pit latrines. So what we did was we collected samples from different heights of the sludge which was accumulated in the pit, and actually developed a method which was followed for all the other pits that have been sampled. Why? Because following previous references coming from Chris Buckley, actually it's possible to discover different layers which are visually distinctive depending on their age or the level of degradation. So, for example, the first layer of the pit was very fresh, and probably the sludge accumulated there was a week old. Then the second layer would be partly degraded. The third layer would be furthermore degraded, and there would be a visual distinction between those two layers. And then the bottom layer was a very thick, dark, soil-like material, which was visibly stabilized or very much biodegraded. So we divided the pit into two sections, the front and the back section, and then collected samples, 4 from the front, 4 from the back. And then the same method was used for each other pit we have been selecting, dry household pit, and compared the data between the different layers or as a composite sample. For the wet VAPs, they're called wet not because there is any flush water used, but because the pit, for some reason, was full of liquid. We established that the most of these pits that we discovered were at the bottom of the hill, and although there was no scientific evidence, we think that there was something to do with underground water infiltration or the effect of the rainy season. So what we discovered was that we had liquid in the pit, and then the sludge was concentrated at the top. So we developed a different method for sampling from this pit because it was not exactly comparable with the previous dry ventilated improved pit latrines. For urine diversion toilets, again, we developed a different type of sampling method, sampling procedure, which incorporated two types of votes, active and inactive vote. The active one was already in use, and the sludge was a lot more fresh. And then for the inactive or the standing vote, the sludge was a lot more dry and stabilized because it hasn't been used for a certain period of time. So the users have been using this valve first. Once it was filled up, they would move the toilet and then start using this one. While they're using the second one, the sludge would be aging and stabilizing in the first vault. For school ventilated improved pit latrines, we had a similar method as for the first one, the household pits. We also had unimproved pit latrines where they have already not been in use at the time we went sampling. And then we just dug holes and collected samples from different levels of the pit. So just to summarize, what is the importance when we develop fecal sludge sampling methods? The sampling should be, first of all, based on the local fecal sludge management context. Why? I was speaking about pit latrines, which are very appropriate for the context of Southeast Africa. But for example, if you go to Southeast Asia, where we have poor flush toilets, and the sludge is collected into septic tanks, then the context of sampling would be completely different. Maybe it would come from the truck, or because the sludge is very much liquid, a different technology would be developed. Then also the sampling methods should fit the end use of the data. So it depends what we need the data for. That's how we need to develop an appropriate sampling method for. For example, if we need a large amount of sludge for testing of a new prototype, then we don't need to collect the different small samples. We need to collect a composite sample of the entire pit. Then the standardized methods should be applicable for the different types of on-site sanitation facilities, what we already mentioned. We can't apply one and the same method for every type of on-site sanitation facility because it won't be applicable, simply. And then the sampling timeline must be coordinated with the laboratory analysis because we would like to avoid storing samples for a long time, and it's better to collect them, to transport and store them for a short time, and then perform the analysis. So from all these selected samples, a number of analyses were performed. That's the list of the analyses that we undertook. However, I have selected just a number of them to show you as an example as well here. For example, if we go to the moisture content, this is the data set we have generated from all the samples and all the repetitions during the analysis. That's why we have a total number of nearly 600 samples. So what we see, for example, in red, we see the dry, ventilated, improved pit latrines, and we see a wide range of moisture content. This varies depending on the location of the pit that the sample was selected, also depending on the number of users, etc., factors that we mentioned early on. So what we observed is that within these pits, we had a variation between 60 to probably 90% of moisture content, where the average, the total average and mean value from all the samples was at about 80%. For the wet VAPs, these are the analyses only from the sludges accumulated on the top of the pit. We have not included the liquid phase. It shows a pretty similar tendency as for the dry VAPs. Then in yellow described all the samples that we have collected from urine diversion toilets. These samples show a larger variation because, as we said, we had an active pit and a standing pit or votes, where in the standing votes the moisture content was much lower because a stabilization process was taken place. And then similarly in the unimproved pit latrines, where the sludge was quite aged, we had a much lower moisture content. If we go to the ash content, we see an even higher variation of the properties. For example, for dry household VAPs, the ash content varies between 0.2 to 0.8 grams per gram dry mass. It is very important to stress on the fact that we have been using dimensions expressing the properties in gram per gram dry or gram per gram total solids. Why? Because all the sludges vary significantly within their moisture content. And unlike wastewater, where the moisture content is over 98, 99%, here we have a large variation, as we saw earlier on. And we would like to have a basis for comparison, a more stable basis for comparison of the data. So that's why we have been expressing it into gram per gram total solids. So we see, for example, here for the urine diversion toilets, we have a much higher ash content, which is also, again, coming from the standing or in the inactive votes. The total COD also varies quite significantly. For the higher values, they usually come from the top layers where we have a very fresh sample. It varies between 0 to, or nearly 0 to 1.6 grams COD per gram total solids or dry sample. We can see that the stabilization process for some of the urine diversion toilets and some of the aged samples from the unimproved pit latrines has taken place. The pH variation was also quite significant. However, we had established a range. The average values, for example, for dry and wet VAPs was something between 7.5 to 8. The calorific value also presented very good variation. There is a correlation between, expectedly, there is a correlation between the COD values and calorific values. The age samples, such as unimproved pit latrines, demonstrated much lower calorific value than some of the fresh samples. Then the average calorific value was about 15 megajoules per kilogram, which is very close to the one of wood. Then if we move to the rheological properties, it was observed that the fecal sludge has a shear thinning with the increasing shear rate, which means that it turns into more liquid with the increasing shear rate, which is good for the design of pit emptying devices and pumping. Then we have particle size distribution within one and the same pit at the different sections, what was demonstrated early on. We did some studies on the trash content of pits or the trash content mixed with fecal sludge in some of the on-site sanitation facilities we have analyzed. We did a manual categorization from 3 or 4 different on-site sanitation facilities. And then we categorized them by different material groups, such as paper, soft plastics, hair extensions, menstrual products, textiles, glass, etc. So what was the distribution? This shows what was the organic fraction, which was attributed to fecal sludge mainly. So it showed a distribution between 85 to 95% by wet mass. And then for the different other material groups, we had a distribution of 2 to 3% by wet mass. So the conclusions of the study, we've already passed through. Most of the information just shows 75 to 85% moisture content for all the VIP samples, 61% for urine diversion toilets. The average calorific value was between 11 to 50 megajoules per kilogram. What we said for the age samples was just 5. It's important also to mention, it didn't come on the slide, but we did quite a lot of analysis on helmet eggs or ascaris content, and most of the helmet eggs demonstrated values higher than the limit set by the World Health Organization, which is 1 helmet egg per gram of total solids, which shows that this sludge needs to be treated further for pathogen inactivation. So just to come up, the most important part of the study was what were the outcomes? We got some results, but actually the most important part was what did we achieve as a result of this study. First of all, we developed a fecal sludge sampling methods and techniques, which also helped us to develop standard operational procedures for analysis of fecal sludge. The study was a baseline for further similar studies by other organizations because we disseminated our knowledge and we collaborated with other organizations to provide a similar platform of study. And then we disseminated the crucial support information required by other partner organizations for pit emptying or other treatment technologies designs. Just to pass quickly to give an example about the different organizations we have been collaborating with. This is just a small list of them, and just to show you what this study helped with or how we collaborated to develop different, to support them in developing different technologies. That's the Asian Institute of Technologies with their solid septic tank and hydrocyclone toilet. California Institute of Technology, Climate Foundation for biochar production of from fecal sludge, nanomembrane toileting, Frankfurt University, Delft University of Technology with their plasma-driven gasification system, Duke University with supercritical water oxidation, blue diversion toilet by EWAG, Omni ingester for pit emptying, the Omni processor for large thermal treatment of sludge, pressure cooker type of treatment. Also, we have North Carolina State University with the excavator for pit emptying, the RTI International with their system, Synergy, etc. So I haven't given any details. They're available on this guideline, which is available to download on the internet or in the course materials. So the overall conclusions of this speech. The good understanding of fecal sludge characteristics is crucial for the improved design of pit emptying devices, transport and processing systems of fecal sludge. Also, they're a baseline for the design of innovative technologies for fecal sludge collection, transportation and processing. And the standard operating procedures for fecal sludge improve the data quality by consistency of the and reliability of the data, comparability of the results from different systems and different regions, and then it provides database generation for fecal sludge. Thank you. For more details, please contact me or visit our website.